Hello. All right, last video in the first unit, and it's going to be nomenclature of acids and hydrocarbons. The acids, because a lot of reactions run faster in an acid environment, so we use a lot of acids in the lab. And hydrocarbons, because our fuel, our burners, are fueled by hydrocarbons. And I chose as my teacher today, I typed in a search for Professor Manatee. I don't know, I just like manatees because, I put on weight, and manatees look like fat because they have a layer of blubber to help keep them warm, and I don't know. I kind of have a kindred spirit with the manatee. But anyway, I'm going to keep this short and sweet. As far as the acids go, a couple things about acids. First of all, you were taught in middle school that acids are chemicals when dissolved in water produce H plus ions, and bases produce OH minus hydroxide ions. And if you put the H plus and the OH minus together, you are required to have a water environment, H2O. So H plus and OH minus only exists in a water environment. So with an acid, first thing, if you see HCl and it has a G next to it for gas, then the actual name of this is the way we would name all ionic compounds. In this case, ionic. I know it looks covalent because it's got two nonmetals, but the hydrogen forms a positive 1 charge. It's in group 1. The chlorine forms a negative 1 charge, and we would just call this hydrogen chloride. However, in a water environment, this chemical, I'm going to write AQ next to it. It means aqueous, water environment. Wow, I can make that a Q. There we go. Aqueous environment. If it has an AQ after it, then we would call this hydrochloric acid. So that's the first thing. You have to make a distinction between whether the material is dissolved in water or not. If it's not, you use your normal nomenclature. If it's dissolved in water, we're going to use an acid nomenclature. All right, so the acid nomenclature, the acids we're going to do, there's two of them. Something we call a binary acid and something we call a ternary, but more commonly called oxoacids. All right, I'm going to start with ternary. Ternary comes from a material that has H plus combined with some sort of polyatomic ion. Now, there is a few exceptions to this. The polyatomic ion has to have oxygen in it, so I'm going to put oxygen in parentheses. And if that happens, then the naming system is pretty easy. It's based upon the group name, and then you just add to the group name ic acid. So I'm just going to write ic, whatever ic acid is the format. So for instance, let's say you had this, H2CO3. Well, H2CO3 comes from, the positive thing is hydrogen, the negative thing is carbonate, which is a polyatomic group, and get carried away there with my negative. And it has oxygen in it. So we're going to use the term ic acid. And it's based upon the polyatomic ion because that's what's going to be different in each of these acids. So the polyatomic ion is carbonate. We replace the 8 with ic, and we get carbonic acid. If we had this, HClO3, well, that comes from H plus, and it also has chlorate, ClO3 with negative charge. Why does that keep happening? Because I'm left-handed and I lean against the tablet. I know why it happens. But anyway, I'm going to act surprised, I guess, every time it happens. So this comes from the polyatomic ion chlorate. So we're just going to call this compound chloric. Get rid of the 8, add ic, chloric acid. Okay? So any of these polyatomic groups, if it has phosphate, it's called phosphoric acid. Notice it doesn't matter how many hydrogens you have. The hydrogens are just there to balance the charge. So carbonate was negative 2, so we needed 2 hydrogens to get my formula H2CO3. If it's nitrate, it's nitric acid. If it's sulfate, it's sulfuric acid. However, if it comes from the polyatomic group cyanide, So HCN, cyanide, is a polyatomic acid, Cn minus. So this comes from H plus Cn minus. Now that's not one of the ones you have to memorize, but this would actually be called hydrocyanic acid. The polyatomic group does have to have oxygen in it. All right, so all the other binary acids, remember binary means it has a positive thing and a negative thing. They use the term hydro whatever ic acid, and you look at the negative component to get the name. So if we had something like this, HBr, well, we know it's an acid. Well, first of all, I'd write aqueous, or I'll just tell you it's an acid on the test. H plus and Br minus, so this comes from bromine, so we're going to use the term hydro because it's binary, not ternary oxo. Hydrobromic acid. Okay, pretty easy. Try these. HF, HI, and let's try H2SE, and then I'm going to mix in a couple other ones here. Let's try H2O, and let's try H3PO4. All right, so pause this, try them, come back. I'll wait. Hey, I waited. We're back. Okay, so I know these are acids because I told you they were all acids, but on a test I would put AQ or tell you it's acid. All right, this comes from H plus, that's how I know it's an acid, F minus, and that's binary. So I'm going to use the term hydro whatever ic, so hydrofluoric, and then yes, you do have to write the word acid. For HI, it comes from hydrogen and iodide, so we call it hydroiodic, sounds weird, acid. And then for this one, is it binary or ternary? It's binary, comes from the element selenium, and so we're going to call this hydroselenic acid. And this one comes from oxygen, and we know it's an acid because it has a hydrogen here, so we're going to call this hydroxodic acid. Notice I didn't write hydroxodic acid because nobody calls it hydroxodic acid, it's water. And then this last one, a little trick, right? Ternary, because it's an oxo acid, it comes from phosphate, so we're not going to use the term hydro, we're just going to call it phosphoric. Phosphate becomes phosphoric acid. Done. Easy. Don't complicate it. Now the fuels we use in the lab are hydrocarbons. And hydrocarbon means it has two elements in it. It has a carbon and it has hydrogen, hence hydrocarbon. However, in organic chemistry, the carbon comes first. So the formulas will look something like this. You have like C3H8. And you'll say, hey, wait a minute. That's a carbon and a hydrogen. How do we name that? Here's how you name it. The name always ends in ane. It's part of a family of hydrocarbons called alkanes. And if we get time, we'll do some more advanced organic stuff, but I doubt if we do get the time. So for now, we're just going to do these simple ones, which are all in a family, an empirical formula family called alkanes. Now, the formula for the alkane, the empirical formula, is CnH2n plus 2. So for this one, if you have 3 carbons and you didn't know how many hydrogens, you could predict that there would be 2n, so 2 times 3 plus 2, 8 hydrogens. And this particular one is called propane. Now, the name comes from the number of carbons, and it's a little different than what we did in the last video. For instance, if you look at the number of carbons in the structure, if there's 1, we're going to have meth somewhere in the name. So yes, methamphetamine is an amphetamine with a 1 carbon stem on it. 2, they use the term eth to represent 2. This is only for carbon structures. 3, they use the term prop. 4, they use the term bute. It's not but. We wouldn't have butane. We would have butane. In fact, there's something called aldehydes, which all end in anal. So if you have a 4-carbon aldehyde, it is pronounced butanal, not but whatever, which is kind of funny because it's got but and anal in the same name. I had a student say that once. I called on them. I was like, Nick, hey, what's the name of this structure? And I had 4 carbons and I had the aldehyde group with it, right? So I had double bond O at the end, put in my Lewis dots, and I had my hydrogens around it. And I was like, Nick, what's the name of this? And he goes, yo, Mr. Burnett, it's butt anal. And oh my God, I died. But back then I was like a first year teacher, so I didn't want them to see me laugh. So I kind of like turned and faced the board and like laughed to myself. But it was absolutely hysterical. All right, let's erase that. All right, so suppose they give you this on a test and they say, all right, we have, oh, I didn't complete the number of carbons, too busy telling my butt joke. All right, 5. Now it goes back to like regular geometry. So 5 is pent, 6 is hex, 7 is hept, 8 would be octane, 9 would be nonane, 10 would be decane, 11 would be undec, 12 is dodec, 13 is tridec, 20 is icosane, 30 is tricosane, 40 is tetrasane, and 100 is killiosane. So we have C7, let's do H16, what's the name of that? So you're like, oh, all right, hydrocarbon, got carbon and hydrogen. So I'm going to base it off of the number of carbons, there's 7, so I'm going to call this hept, and then I'm going to add the family name, the empirical family, ane, heptane. What if they give you this on a test? Now, in organic chemistry, we don't care about the hydrogens. So a lot of times what they'll do is they'll write the structure out like this, and they'll say, all right, here's the dashes connecting the hydrogens, but where'd you go? We don't care about the hydrogens, so what we're going to do is we're going to leave them out. We assume if there's a dash to something and there's nothing there, it's hydrogen that's there. All right, so we go 1, 2, 3, 4, 5, 6. We count the carbons. There's 8 of them. So this is going to be 8 carbons, which is oct, and then we end it with ane. Here's another way they could present it. What if they gave you this? CH3, CH2, 7, and then CH3. Well, how many carbons do we have? We know from our atom inventory, we have a total of 9 here. 1 on each terminal end, and then in the middle, there's 7 CH2 groups. That's a total of 9 carbons. So this is going to be known for 9 and ane. What if they did this? All right, well, that's our bond line structure. That means we know there's a carbon here, a carbon here, a carbon here, a carbon here, 4. So we would call this butane. So on the test, if I give you the name and you want to draw a structure, if it's a FRQ, a free response question, I'll accept any of these. I'll accept condensed structure, bond line, a chemical molecular formula, or I will accept this skeletal structure. Any of them would be fine. All right, so suppose I gave you this on a test. I said, all right, give me the formula for undecane. And you're like, all right, well, you know, Burnett didn't say what type of formula, so I can put anything I want. If I want to do molecular formula, I would say undec means 11 carbons, so that means I have to have 2 times that plus 2, so 24 hydrogens. I'm done. And Burnett would have to accept it. Or, pardon me again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then I can put in all my little sticks here for my 24 hydrogens. Oh my gosh, I'm cramping. I didn't stretch before I started writing this. What is this symbol at the end? It's a rhombus. Trapezoid? I don't know, trapezoid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so I'd have to accept that. Or remember, if we want to do condensed structure, we have a CH3 here on each end. And then we have CH2s in between. So we could write CH2, parentheses 9, and then another CH3. And I would have to accept that as well. And then finally, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But undecanes, 11. So there we go. We're done. But you don't have to draw all 4 of these. You could just draw one of them. And that's it.